All right, so let's talk more about intersecting lines in circles. If two lines intersect a circle, there's three places where the lines can intersect. They can intersect on the circle, which is an inscribed angle, which we talked about in a previous lesson. There's over here outside the circle, which we will talk about in the next lesson. What we're going to focus today is when they intersect inside the circle. So here we have two chords intersecting inside of a circle. Of course, when any two lines cross, they intersect, they form a set of vertical angles. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. But what does that have to do with the circle? Great question. Well, what we'll find is that the measure of angle 1 is going to be a factor of the two arcs that impact angle 1. And what we have here is the measure. Actually, let's get to our purple color. The measure of angle 1 equals 1/2 the measure, and let's measure of arc AD plus the measure of arc BC. And the measure of angle 2 is going to equal 1/2 times the measure of arc arc B plus the measure of arc CD. So if we take the two arcs, add them, take half of it, then we will have the measure of our angles. So let's look at an example. Here we have JK. So the measure of arc JK is 130 degrees, and the measure of arc ML equals 156 degrees. So if we start with our theorem, the measure of angle X equals 1/2 the measure of arc JK plus the measure of arc ML. And then we can substitute X equals 1/2 130 plus 156. Let's get a little more room. X equals 1/2 286. So X is going to equal 143 degrees. And we